In this video, I'm planning on going over a bunch of examples showing how to balance chemical equations. The best way to learn how to balance chemical equations is to just do lots of them and get lots of practice. So first of all, what does it even mean to balance an equation? What it means is, so remember going back to the conservation of mass. So with the conservation of mass, we can't create or destroy atoms. All we're doing in chemical reactions is rearranging atoms. So let's say, for instance, we have we don't have H2O. So let's say we have hydrogen and we have oxygen, and these are forming to make H2O. So we're taking hydrogen gas and oxygen gas and we're making water. So we can't create hydrogen or destroy hydrogen. All we can do is move hydrogen, and in this case oxygen, around to form a different compound. And in the chemical equation, the parts of your equation that are reacting, these are called the reactants. And the whatever's on your right side of the equation are your products. So in order for a chemical equation to be balanced, we have to have the same number of each type of atom on each side of the equation. So what that means is we want to have the same number of hydrogens on both sides of the equation, and we want to have the same number of oxygens on both sides of the equation. So what we do is do an inventory of what we have on each side. So I usually just draw a line in the middle where the arrow is, and I list what I have on both sides. So on this side I have 2 hydrogens, so I have the H and then I have 2, and this is showing that we have 2 hydrogens and they're bonded together in this compound, and then we have 2 oxygens. And then I just list what I have on this side. So I have hydrogen and oxygen on this side. So looking at what we have here, we have 2 hydrogens and we have 1 oxygen. So is this equation balanced? No, it's not, because we have a different number of oxygens on both sides. This side of the equation we have 2 oxygens and we only have 1 oxygen on this side. So the way that we balance this is we need to add more oxygens to this side. So the way we're going to do that is put a 2 here, and so now and then we just add up what we have again. So now we have 2 oxygens, so I'm going to cross that out and put a 2. But by doing this, we also changed the number of hydrogens. So now we have 4 hydrogens on this side. So now we need to go back and look. Okay, now the oxygens are balanced because we have 2 on both sides, but now the hydrogens aren't balanced because we have 4 hydrogens on this side and 2 on this side. So we need to add more hydrogens to this side. So I'm going to put a 2 here in front of that hydrogen, and so now I have 4 hydrogens. And one thing I want to point out, so this equation is now balanced. We have 4 hydrogens on both sides and we have 2 oxygens on both sides. One thing I want to point out, when you're balancing equations, you always put the number right here on the left side. This is showing that we have 2 water molecules. What some people do that can be really tempting is, let's go back to our unbalanced equation. So we have H2O2 and then H2O, and let's list what we have. So we have the hydrogens and oxygen. We have 2 of each of these. we have 2 hydrogens and we have 1 oxygen. What can be really tempting is to just put a 2 here. And now we have 2 oxygens on both sides. The problem is now we're changing what our reaction is, because in this reaction we're combining hydrogen and oxygen to get water. And in this reaction it's combining hydrogen and oxygen, and this is hydrogen peroxide. So this isn't water. So you can't just change the subscript here, because this changes what your compound is. So you're saying that you have a different product than what you actually have. So the reason why we put the 2 here is because this is saying that now we have 2 waters. If we put the 2 here, now we have 1 hydrogen peroxide. So we put the 2 here, that's showing that we have 2 waters. And the same thing coming over here. So after we put that 2 there, we had 2 oxygens and 4 hydrogens. Now we need 4 hydrogens. You can't just do that. So this is, I don't even think this is possible, but this is this would be different from H2. So we need to put the 2 here, and that's showing that we have 2 hydrogen gas molecules. Okay, so let's do another example. Do nitrogen plus hydrogen, and we're getting this. So we want to balance this equation. So we're going to do our inventory of what we have. So on this side we have nitrogen and hydrogen. There's 2 nitrogens and there's 2 hydrogens. And on this side we also have nitrogen and hydrogen. We have 1 nitrogen and we have 3 hydrogens. So what I'm going to do is I'm going to balance the nitrogen first. So I have 2 nitrogens on this side, and I have 1 nitrogen on this side. So what I'm going to do is put a 2 here, and then I have 2 nitrogens, and I have 6 hydrogens, because I have this molecule that has 3 hydrogens. I have 2 of them, so now I have 6 hydrogens. So now I need to balance the hydrogens. Now I have 6 here and 2 here. So I'm going to multiply this hydrogen by 3. So now I have 6. So now let's just double check this. So I have 2 nitrogens on both sides, and I have 6 hydrogens on both sides. So this equation is now balanced. And one thing that I normally do is I balance the hydrogens last. So like in this equation, I balance the nitrogen first, and then I balance the hydrogen last. Let's say that we have methane plus oxygen, and we're getting carbon dioxide and water. So you should be able to recognize this as a combustion reaction. That doesn't matter for this video because we're just balancing chemical equations, but a combustion reaction always has something reacting with oxygen, and your products are always going to be carbon dioxide and water. Okay, so let's balance this equation. So we just want to inventory what we have on both sides. So here we have carbon, hydrogen, and oxygen. We have 1 carbon, 4 hydrogens, and 2 oxygen. So I just looked at what I had for like how many of these I had in this molecule and then in this one. Now I'm just going to list what I have on the other side. So on this side I have 1 carbon, I have 2 hydrogens right here, and then this one is a little bit, so we have oxygen in more than one product. So we need to add up all of the oxygens. So we have 2 oxygens here, and 1 here. So 2 plus 1, we have 3 oxygens. Now, to balance this, I had said previously that I left hydrogen to last, and generally I do, but in cases where you have an atom, in this case we have oxygen that's in more than one of the products, so it's in 2 of the products. We want to leave that to last. And the reason why is it's just going to make the process of balancing the equation easier. If you did oxygen before hydrogen in this case, you would still get the right answer, but it would be a little bit more confusing. So for this, normally we would want to balance the carbon first. The carbon is already balanced, so I'm not going to worry about that. And then I'm going to do the hydrogen. And like I said, normally I would do the hydrogen last, but since I have oxygen in more than 2 of the products, I'm actually going to do the oxygen last. So looking at the hydrogen, we have 4 hydrogens on this side and we have 2 on this side. So we need 2 more on this side. So we're going to get those by multiplying this water by 2. So now we have 4 hydrogens, and we also changed the number of oxygens, so we need to figure out what that is. So now over here we have 2 water molecules. Each water molecule has 1 oxygen. So that means that we have 2 oxygens here and we have 2 here. So 2 plus 2 is 4. Now we want to balance the oxygens. So we have 4 oxygens here and 2 here. So we need 2 more here. So we're going to multiply this O2 by 2, and now we have 4. So let's just look at this. We have 1 carbon on both sides, 4 hydrogens on both sides, and 4 oxygens on both sides. So this equation is balanced. Let's do another one. This is another combustion reaction. So we have C3H8. So we have a hydrocarbon, and it's reacting with oxygen, and we're getting carbon dioxide and water, so CO2 plus H2O. So to balance this, we just do our inventory on both sides again. So we have carbon, hydrogen, and oxygen. We have 3 carbons, we have 8 hydrogens, and we have 2 oxygens. Now let's go over here and figure out what we have on this side. So carbon, hydrogen, and oxygen. Over here we have 1 carbon, we have 2 hydrogens, and we have once again we have oxygen in both of our products. So we need to count all of them. So we have 2, 3 oxygens. Okay, so in this equation, I'm going to balance the carbon first. So oxygen and hydrogen are usually left until last, and usually you do hydrogen very last. But in this case, I'm going to actually do oxygen very last, because like that equation, we have oxygen in 2 of our products. So we actually want to do oxygen last this time. So I'm going to start with the carbon, do the hydrogen, and then the oxygen. So for the carbon, I have 3 carbons here, and I have 1 here. So I need 3. So I'm going to put a 3 in front of the CO2. So now I have 3 CO2s. That means that now I have 3 carbons. And I also changed the number of oxygens. Now I have 7 oxygens. Now what I want to do is balance the hydrogens, because since I have oxygen in 2 of my products, I want to do the oxygen last. So now I'm going to balance the hydrogen. So I have 8 here and I have 2 here. So I need to multiply the hydrogens on this side by 4 to get 8. So I have 4, and then now I have 8 hydrogens here. But I've also changed the number of oxygens. So now I have 6 here and I have 4 here. So now I have 10 oxygens. And then last, I'm going to balance the oxygens. So I have 10 oxygens over here. I have 2 over here, so I need to multiply the oxygens over here by 5. So I put a 5 in front of this oxygen. Now I have 5 times 2, I have 10 oxygens. So I have, looking at both sides, I have 3 carbons, 8 hydrogens, and 10 oxygens. So this equation is now balanced. Okay, I'm going to erase this and do some more. Let's look at this equation. So we have 3 chloride plus sodium chloride, or sorry, sodium hydroxide, and we get this. Okay, so we're given this equation and we want to balance it. So what we need to do is inventory what we already have. So on this side we have iron, we have chlorine, we have sodium, we have oxygen, and we have hydrogen. So we have 1 iron, we have 3 chlorines, we have 1 sodium, we have 1 oxygen, and we have 1 hydrogen. Now coming over here, I'm going to list what I have on this side, and I have the same things on this side, but they're in a different order, but I'm going to list them in the order that they're on this side so it's easier to compare across what I have. So I have, so on this side I have 1 iron, and then this is a little bit different. So, so we have this OH in parentheses. So what that means is that we have this OH, this is a polyatomic ion, and we have 3 of them. So that means that we actually have 3 oxygens and we have 3 hydrogens. So I'm going to put the 3 oxygens and 3 hydrogens. And then we have 1 sodium and we have 1 chlorine. Okay, so to balance this, I'm going to do the oxygen and hydrogen last. And I'm just going to start with iron. But iron is already balanced, so I can go on to chlorine. So I'm going to balance the chlorine. So I have 3 chlorines on this side, and so that means I need 3 on this side. So I'm going to put a 3 in front of this sodium chloride. So now I have 3 chlorines. But I've also changed the number of sodiums. Now I have 3 sodiums. So that means that now I need to balance the sodium. So now I have 3 on this side, and I need 3 on this side. So I'm going to put a 3 here. So now I have 3 sodiums, and I've also changed the number of oxygens and hydrogens. So now I have 3 oxygens, and I have 3 hydrogens. So let's just look at this and see if it looks balanced. So we have 1 iron on both sides, 3 chlorines on both sides, 3 sodiums, 3 oxygens, and 3 hydrogens. So this equation is balanced. Now let's do this one. Let's say that we have sodium and it's reacting with water, and we're getting sodium hydroxide and hydrogen gas. Okay, so we're just going to do an inventory of what we have on both sides. So we have sodium, we have hydrogen, and we have oxygen. And then coming over here, we're just going to list these. So sodium, hydrogen, and oxygen. So we have 1 sodium, we have 2 hydrogens, and we have 1 oxygen. Now we just list what we have over here as well. So we have 1 sodium, 1 oxygen, and then we have hydrogen in 2 of our products. So we need to add them all up. So we have 2 here and 1 here. So we have 3 hydrogens. So what I'm going to do is, normally I would leave hydrogen to last, but right now we definitely want to leave it to last because we have hydrogen in 2 of our products. But looking at this, so we would start with sodium. Sodium's already balanced. Look at oxygen. Oxygen's balanced. So the only thing we need to balance is actually the hydrogen, or at least to start. So what I'm going to do is so I have 3 hydrogens over here and 2 over here. So this seems kind of like, well, how in the world am I going to get the same amount on both sides? Well, probably the easiest way to do this is just start out by multiplying, say, this water, so the hydrogen that only has 2. So we're going to multiply this water by 2 and just see where that leads us. We might need to go back and do another multiple later, but we'll just try this first. So now we have 4 hydrogens, and we've changed the number of oxygens too, so now we have 2 oxygens. Now what I want to do is balance the oxygens, because now I have both oxygen and hydrogen that are unbalanced, but over here I have 2 hydrogens as a product. I have hydrogen in both of my products, so I want to balance the hydrogen last. So I'm going to go back and do this oxygen. So I have 2 oxygens here, and I have 1 oxygen here. So what I need to do is multiply the oxygen on this side by 2. So I'm going to multiply the sodium hydroxide by 2, and so now I have 2 oxygens, but I've also changed the number of hydrogens, so now I have 2 hydrogens plus 2 hydrogens here, so I have 4 hydrogens. So just looking at, let's just check and see if this is balanced. So I have 1 sodium, 4 hydrogens, and 2 oxygens. So this equation is balanced. So I'm going to erase this and do some more. So I have silver oxide, and I'm getting silver plus oxygen gas. So I want to balance this equation. So I'm going to draw my line and then do the inventory. So I have silver and oxygen, and I have 2 silvers and 1 oxygen. And then I'm going to do the same thing over here. So over here I have 1 silver and I have 2 oxygens. So for this equation, normally, like if I have silver and oxygen, normally I would balance the silver first and then the oxygen. But in this case, since I have silver by itself, I also have oxygen by itself, but I'm going to actually balance the oxygen first. So I have 2 oxygens here, and I have 1 here. So what I want to do is multiply this oxygen by 2. And so I need to multiply the silver oxide by 2. So if I do that, I have 2 oxygens, and now I have 4 silvers. So now the oxygens are balanced, and I want to balance the silver. So I have 4 silvers here, 1 here, so I need to multiply this silver by 4, and now I have 4. Okay, let's do another one. So say that we have phosphorus plus oxygen, and we get this. So we want to balance this equation. So what I'm going to do is draw a line, and so I have phosphorus and oxygen. I have 1 phosphorus and I have 2 oxygens, and over here, so I have phosphorus and oxygen, and over here I have 2 phosphorus and 5 oxygens. So with this too, normally if I had phosphorus and oxygen, I would balance the phosphorus first, but I think in this case I'm going to actually do the oxygen first, because I have phosphorus here by itself, so I know that that's going to be easy to balance after I balance the oxygens. So let's, so I have 2 here and I have 5 here. So what I need to do is actually figure out a multiple that these both have. And so that multiple is 10. So what I want to do is put 10 electrons, 10 oxygens on each side. So to get 10 over here, I'm going to multiply this whole thing by 2. So now I have 2 times 5 is 10 oxygens, and 2 times 2 have 4. Now coming over here, I would need to multiply this oxygen gas by 5. So now I have 10 oxygens. So the oxygens are now balanced. I have 10 on both sides. Now I need to balance the phosphorus. So I have 4 here, and I have 1 here, so I need to multiply this one by 4, and then I get 4. So this equation is now balanced. And I just want to tell you that if you say you had to balance the phosphorus first and the oxygen second, you would have ended up with the same answer. It would have just taken a few more steps of going back and forth. So it doesn't really matter which one you balance first. You're going to get the same answer. It's just that as you balance more equations and get more experience, you'll start to recognize what atoms you can balance first and balance the equation in the least number of steps. So learning how to balance these equations, the easiest way to get good at it is to just do a whole bunch of them. So let's do a few more. We have this SiO2 plus carbon, and we get SiC plus CO. Okay, so we want to balance this equation. So we're going to draw our line and list what we have. So over here we have silicon, oxygen, and carbon. So I'm going to list the same things on this side. So silicon, oxygen, carbon. So for this, so the silicon dioxide, I have 1 silicon and I have 2 oxygens, and then I have a carbon here. So I have 1 carbon. And then over here, I have 1 silicon, 1 carbon, I actually have carbon in 2 of my products, so I have 2 carbons, and I have 1 oxygen. So now what I'm going to do is, since I have carbon, well, first of all, the silicon is already balanced, so I'm not going to worry about that for now. And then the next one I would normally do is carbon and do oxygen last, except that I have carbon in 2 of my products, and I also have a carbon sitting here by itself. So I think carbon is going to be easiest to balance last. So I'm going to do the oxygen next. So I have 2 oxygens here and 1 here. So I need to multiply the oxygen on this side by 2. So now I have 2 oxygens, and I've changed my number of carbons. So I have 2 carbons here and 1 here. So I have 3 carbons. So now I just need to balance the carbons. So I have 3 carbons here and 1 here. So I just need to multiply this carbon by 3. So now I have 3 carbons, and this equation is now balanced. Okay, let's do this one. So I'm giving you the answers. So I have aluminum plus sulfuric acid, so H2SO4, and those are reacting to form aluminum sulfate plus hydrogen gas. Okay, so we want to balance this equation. So we're going to draw our line and then do our inventory. So we have aluminum, we have hydrogen, sulfur, and oxygen. So we have 1 aluminum, 2 hydrogens, 1 sulfur, and 4 oxygens. And then I'm just going to list them on this side in the same order. So aluminum, hydrogen, sulfur, and oxygen. Now I want to add up what I have. So I have 2 aluminums. And then I'm just going to put the 2 hydrogens here. And then remember, so we have this SO4 in parentheses. That means that we have 3 of this SO4. So this might be a little bit confusing. But what this means is that we have this, we have sulfate, and we have 3 of them. So that means that we're going to have 3 sulfurs, and each of these ions has 4 oxygens, and we have 3 of them. So that means that we have 3 times 4 oxygens. So that means that we have 12 oxygens. Now what I want to do is I'm going to leave the oxygen and hydrogen to last. So I'm going to go ahead and balance the aluminum. So I have 2 aluminums here. Well, actually, I'm going to leave the aluminum for now too, because I have aluminum sitting by itself right here. So I think I actually want to do the sulfur first. So I have 3 sulfurs here and 1 here. So what I need to do is multiply this sulfur by 3. So I do that by multiplying the entire sulfuric acid molecule by 3. So now I've changed a whole bunch of things. So now I have 3 sulfurs, but I've also changed the number of hydrogens. So now I have 6 hydrogens, and I have 12 oxygens. Now I want to balance the hydrogens. So I have 6 hydrogens over here and 2 over here. So I need to multiply this hydrogen by 3. So now I have 6 hydrogens here. And then I want to balance the aluminum. And just to go back a step, the reason why I left aluminum until last is because I have aluminum sitting by itself right here. And so it's going to be really easy to balance that. If the aluminum wasn't sitting by itself right there, I would have balanced aluminum first. So this is just an exception to what you would generally do. So I have 2 aluminums here and 1 here, so I just need to multiply this aluminum by 2, and I get 2. So now we have 2 aluminum, 6 hydrogen, 3 sulfur, and 12 oxygens. So this equation is balanced. And I just want to emphasize that you could have balanced these in any order, and you would have ended up with the same thing. If you, like, say you didn't know that, it will be easier if you balance aluminum last in this particular case, don't worry too much about it, because as long as you balance each thing one at a time, you're going to end up with the same answer. It just might take more steps. Okay, so I'm going to erase these and do one more. Let's do NH3 plus copper oxide, and we get copper plus nitrogen plus water. So this time we have 3 products, and so we want to balance this equation. So we're just going to do the exact same thing we've been doing. We're going to list what we have, so do an inventory. So we have nitrogen, hydrogen, copper, and oxygen. So we have 1 nitrogen, we have 3 hydrogens, we have 1 copper, and we have 1 oxygen. And then I'm just going to list these on this side, so nitrogen, hydrogen, copper, and oxygen. And now I'm going to add up what I have on this side. So I have 2 nitrogens, I have 2 hydrogens, I have 1 copper, and I have 1 oxygen. So what I want to do is actually balance the nitrogen first. So copper is already balanced, and oxygen is, and I'm going to leave hydrogen for now, so I'm going to balance this nitrogen. So I have 2 nitrogens here, and I have 1 over here, so I need to multiply the nitrogens on this side by 2. So I'm going to multiply this by 2. So now I have 2 nitrogens, and I have 6 hydrogens. So now my nitrogens are balanced and my hydrogens aren't. So now what I want to do is balance the hydrogens. So I have 6 hydrogens over here, 2 here, so I need to multiply the hydrogens on this side by 3. So I'm going to multiply this by 3. And so now I have 6 hydrogens, but I've also changed the number of oxygens. So now I have 3 oxygens. So now what I need to do is balance oxygen. So I have 3 oxygens here and 1 over here. So I need to multiply these oxygens by 3. So now I have 3, but I've also changed the number of copper now. So now I have 3 coppers. And then coming over here, now I have 3 coppers here and 1 here. So I need to multiply this copper by 3. So now I have 3. So now let's just look at what we have. So we have 2 nitrogens, 6 hydrogens, 3 coppers, and 3 oxygens. So just as a recap for balancing chemical equations, I think this one is a good example of this concept. You just want to step through and balance one atom at a time, and if you do this in steps, I think it's going to go pretty smoothly, and you're going to get the right final equation. So just do this in steps, write everything out, because if you try and do this in your head, it's going to be really hard. And so write everything out, just change the numbers, like cross out the number and change it, don't try to erase. And the general rules are that you do oxygen and hydrogen last, but as you've seen from some of these examples, there's some exceptions to that. So the best way to get good at this is to just practice doing a whole bunch of examples. So I hope this video was helpful. Thanks for watching.